It's two different concepts that are actually very related to each other. So as you can tell, there's a lot to cover today. In JavaScript, everything that we've dealt with basically is what we call a data type. And there are several main data types in JavaScript, but one way to bucket them or to differentiate them is between what we call mutable data types versus primitive or immutable data types. Sorry, this is a comment here. Oh, okay. So really quickly, for folks who are having trouble finding the lecture slides, if you look on my screen, if you click into here, you should see this boot symbol on the top right-hand corner, top left-hand corner of your screen. If you click into that and then click into the materials tab, you should see the PDF of the slides there. Okay, just in case anyone else is also having trouble finding it. Okay, so sorry. So as I was saying, there's two main buckets of data types in JavaScript. The ones we call primitives and the ones we call mutable or changeable, if you prefer that way. Almost all the data types we've seen so far in this class, so the numbers and the strings and the booleans, those are all what we call primitive data types, which means we cannot change them. And we'll talk about what it means to change or not change a particular data type. There are a few other primitive data types as well. So those are the nulls, the undefineds, and the symbols, which we don't really cover in this class. But basically those 5 things, numbers, strings, booleans, nulls, and undefineds, those are the primitives. And then we'll talk about the non-primitives or the immutable, or the mutable data types when we cover arrays, functions, and objects. Okay. So for now, when we talk about when I say a primitive data type, for now we can just think of it as numbers, strings, and booleans. All right, so the other way is the non-primitives for the complex data types, which are functions, arrays, and objects. So what does it mean when I say something can or cannot be changed? Well, I think you actually saw an example of that yesterday when you were doing the crazy caps problem, where the goal of the problem was to capitalize every other letter in a string. One thing you probably noticed there is that when you did that, right, you couldn't go into the string and just change a letter, right? We almost had to recreate a new string from scratch by going through the other string, taking every letter and kind of adding it to our original string, right? So that's like at the core of it. That's what we mean when we say something is immutable, is you can't change that, right? That string, once it's been created, no one can ever change it. The only thing we can ever do is create a new string with the changes we want to see, right? Which is what we did last night. If I gave you a string and asked you to capitalize every other letter, I couldn't change the original string. I had to create a brand new string in which I capitalized every other letter. Okay, so that's all it means when we say something is changeable versus not changeable. We'll contrast this when we talk about our section, let's for example on arrays, right? Where if I have one array and I want to change it, I can just change that directly, right? With a string or a number or a boolean, I can't change that. What does it mean when I say you can't change a number? Well, I can say let x equal 6, but 6 will always ever only be 6. I can say x equals 9 later on, right? And I can give x another value, and that's totally fine. But I can never give 6 another value, right? 6 is always 6. A string is always going to be that string. And with booleans, obviously, true is always going to be true, and false is ever going to be false. These are things that we are not able to change once we've created once we've created it or are using it. So coercion then is this idea of, well, coercion, just in plain English, right? It just means to change. And so in programming, whenever we say let's coerce something, all we're saying is let's change something from one data type to another data type. So the types that we talked about so far for the primitives are numbers, strings, and booleans. And when we talk about coercion, all we're saying is let's change it from one of those types to another one of those types. Okay. So the first one that we're talking about is actually pretty straightforward. It's called explicit coercion, and as the name indicates, it's just very, very clear what we're doing. Here on line 6, you'll notice we have this let num equals 10, and when I do type of num, on line 9, I create another variable, lowercase string, called string. I set it equal to, and notice how on the right-hand side of the equal sign on line 9 there, the S in string is capitalized. If you remember what we said on day 1 about naming variables, right? I said that in JavaScript, whenever you capitalize the first letter in a variable, it usually means you're talking about a class, which is a very specific thing. And as we're going to soon see, every data type in JavaScript that we've dealt with so far, numbers, booleans, strings, as well as arrays and objects, they all are built into JavaScript, and therefore they all have their own classes. Okay, we're not going to go deep into classes in this session, in this curriculum, except here I'm just going to say that if I want to take something and convert it into a string, all I have to do is call the class and pass in that thing that I want to change in as the first argument. So here on line 9, what I'm doing on the right hand side is I'm taking num, which was previously the number 10, I'm passing it into the string class, and the string class is going to say, hey, here's a string or a stringified version of the number 10. So when I console log out string and type of string, if I take a look on the upper right hand corner there, on line 7, when I console log out type of num, I get number, right? Type of 10 is a number. And then on line 9, I pass in the number into the string class. On line 10, when I console log out string, I still get what appears to be 10, but when I console.log type of string, it's actually a string. So at that point, it's no longer 10. It's actually a string with 2 characters, 1 and 0. Okay, this is all explicit coercion is. It just means here we're being very, very clear that in this case we're changing whatever num is, we're changing it into a string because we are invoking the string class. Similarly, I can move pretty fluidly between these different types, right? So on line 6, I create a string of 4 characters, 1 0 0 0, and on line 9, I'm going to say, well, I want to change that into a number. So then I actually use the number class, and just like with string, if I want to change them into a number, I call the class, I pass in the value as the first argument on line 9, and when I take a look at the output, I started off with a string, and then when I console log it, it looks like the same as a string 1 0 0 0, but when I do a type of, it's actually not a string anymore, it's now a number. Okay, everyone good so far?
Yes.
Okay, I've been burned by the yeses before, so I'm just gonna sit tight for another few seconds in case anything else comes up. But hopefully this is fairly straightforward in terms of saying, look, everything that we're doing is very clearly like outlined, right? It's very explicit. There's no guesswork. So the converse of explicit coercion then is implicit coercion, which means we're still changing something from one type to another, but it's a little bit kind of, you need to I'll say read between the lines. Okay. So, and I sometimes I don't go through every single slide just because I'll be verbally talking about the concepts anyways. But like I said, you do have all the slides at your disposal if you want to take a look at the content later on. So here on line 1, I have this variable called sum, and it's equal to 10 plus 20, and those two are both numbers. On line 3, I have this variable called concatenated string, and it's equal to the string 10 plus the string 20. And so line 1, it's pretty straightforward, right? 10 plus 20 is 30. Cool. On line 3, what's one string plus another string? Well, we shove 2 strings together, so it's going to give me the string 1020. But what happens on line 5? What happens if I try to add in a number to a string? And I'm not going to keep you in suspense for too long because it is a Friday night. But the answer is, actually, when you try to add in a number to a string, in JavaScript, what it does for you behind the scenes is it actually converts both parts of it into a string first, and then it does the plus operation, right? Then it does the concat operation. And so because of that, here we see an example of what we call implicit coercion, right? As in, nowhere do I ever explicitly say, hey, let's change that 10 to a string. But when I use the plus operator and I put in a number plus a string, JavaScript says, well, now if I see a number and a string and a plus operator, that just means I'm going to change both things into a string first and then do the concatenate operation on them. So this is one example of an area in which, unfortunately, you just kind of need to keep in the back of your mind that when you add a number to a string, both things get converted to a string first, and then they're quote unquote added or concatenated together. Okay. Now, one thing to keep in note with how these operators work is, remember, JavaScript reads code for the most part top down, right? It reads it left to right. Okay. except of course in this case on line 7 you have an equal sign, right? So it reads the right hand side of the equal sign first. So on line 7 here, notice how we have this string 1 0, and we're adding 20, 30, 40, and 50 to it. Now, if I console log out what this gets, well, if I was to computer, I was going from left to right, I would get, well, what's the string 10 plus 20? Well, I convert both things to a string, so now it's 10 plus 20, so I get 1020. Great. What's next? Well, what's 1020 string plus 30? Well, I convert both things into a number. Sorry, I convert both things into a string, and then I concatenate them together. So I do that over and over again. And by the time I'm done, I don't have a number. I have the massive string with 1020, all the way down. Okay. This is an example of the computer going from left to right. However, if I have this example here on line 7, if I follow the same operation, or bad choice of words, if I follow the same process that I did on the previous slide, now if I start from left to right, well, what's 10 plus 20? Well, that's 30, right? Basic math. Okay, what's 30 plus 30? 30 plus 30 is 60. Okay, what's 60 plus 40? That's 100. And what's 100 plus the string 50? Now, here's where implicit coercion, or here's where the plus operator comes into play and says, well, you have a number and a string, so let me turn them both into strings first and then add them together. And so when we actually print this out, what we get is a string because we see there's a string there on line 7, but it's actually not the same string as before. It's actually 10050. And the reason for that is because as the computer reads from left to right, it will only read each operation one at a time. And so in this case, it actually is able to do math for the first 3 operations until it gets to the very last number, in which case it converts it into a string. Okay. One of the things that we're going to talk about, or one of the things that we're talking about in this course is we're going to do a lot of comparisons. And as a good rule of thumb, you should in JavaScript there exists 2 ways to compare something, right? One is to say, well, I can just type in 2 equal signs, and the second way is to say I can type in 3 equal signs. So for the purpose of this class, and honestly, and generally in programming, you should always use triple equal signs. Okay, there are rare edge cases in which you will want to use 2 equal signs, but for everything in our curriculum, you always want to use triple equal signs. And the reason why is because what triple equal sign does is when you compare 2 things with triple equal signs, it will make sure that the 2 things are of the same data type and have the same value. Okay, if you only use double equal signs, then what it does is it actually tries to convert both things into the same data type first and then compares it for you. But that conversion process is sometimes very not intuitive, and it's actually incredibly difficult to figure out what it's actually very difficult to figure out what something is or what's happening behind the scenes. And so for that reason, as a rule of thumb, we should always be using triple equal signs whenever we compare any 2 things in JavaScript, any 2 primitive data types in JavaScript. Okay, so once again, triple equal signs means same type and same value. Double equal sign says, let me try to convert the types for you first and then do the value, and that has a lot of unintended consequences. Okay, that's right. Any questions so far? We've done a lot of numbers and string conversions, and we're talking about booleans next, but I'll pause here for a few seconds for any questions.
Yes, I have a question. Yesterday, I attended the full stack bootcamp exam question review, and one of the questions said to return the string true, or return the string false if whatever the condition meant, whatever, if it's false, whatever. And the instructor put the word true in quotes, and the test cases came out correct. But I put the word true without quotes, and it also came out as correct. Why is that? Is it because JavaScript did the implicit coercion for the word true?
I would need to see that code in that test. It depends on what the test is checking for.
Okay.
My guess is the test is probably was a bit more vague than it should be. If something is saying return the string true, then theoretically it should check type first, and then it should check value. And if you're returning the boolean true, then it should fail on that first test. Now,
Got it.
the question may be written in a way that allows both values, but inherently those two are not the same thing. They're fundamentally different.
David, if you a string with anything inside of it returns true though, as long as it only returns false when it doesn't have um, anything inside of it though. So that might be why it made sense and it returned true.
Right, but it shouldn't. Like if I'm saying like if I have a function that and my request to you is have it return the string true. I'm not saying return the Boolean version of whatever it is you return, and that has to be true, right? It should be returning the actual string true. So we're actually going to talk about like that in the next few slides when we talk about Boolean coercion. But like I said, like that depends on the way on the problem was written and kind of how loosely I guess the author wanted the results to be. Cool. All right. Any other questions?
Yeah, David, I have a question.
Go ahead.
Can you just briefly state how mutability relates to coercion? Oh, I'm not clear on that.
Mutability. So mutability, how I word it. So coercion is just changing something from one type to another type. And so far we've only dealt with primitives. So mutability has actually not been a concern for us. And it actually won't be for today's lesson. But essentially, we just want you to kind of like the question that we sometimes get is like, hey, how come I can't change a string, right? And the reason and the answer is because it's immutable. And so then if there are other questions like, well, what if I want to, is there what are ways I have to edit a string? Well, we can say you can change it into a mutable data type, right? For example, you can convert a string to an array of characters. But for today, so far, for our topics on coercion, there's no direct link to mutability yet.
So is mutability more like about the value of it versus the type?
Mutability is whether or not I can change the value of something. Absolutely. The type is so data types are either mutable or not mutable, right? So if a data type is not mutable, then whatever value you use in it is also it's also not mutable. Okay, so when you think about coercion and mutability, like they're not things that you quote unquote use, right? Like mutable is almost like a property, right? Like if I say a car is red, like it describes a feature of the car. Like I don't use that red for anything, right? Similarly, when I say like, oh, this data is mutable, it just means, oh, that just means there are things I can do with it and things I can't do with it, right? Coercion, on the other hand, is an explicit action. Coercion says, hey, I want to change something from type A to type B.
Okay, I think I get it.
Yeah, yeah. So you'll never hear anyone say, let me use mutability, but you will say someone say, hey, let me coerce this from A to B.
Okay, thanks.
Cool. All right, so yeah, so maybe I think your questions are all of your questions are leading into kind of something around like, okay, so how does this work kind of on like in a further step, right? So the next step of coercion then becomes Boolean coercion, and this is actually very, very common because if you think about the way a computer, like operates deep down, it's just a lot of zeros and ones, but just a lot of zeros and ones, right? There's two possible values, a 0 or a 1, and computers absolutely love. I mean, every problem that you write, everything you write in a computer eventually boils down to 0 or 1, true or false, right? Yes or no. And so that's why Boolean coercion is actually very common too, because it's actually the easiest kind of logical split you can have. So Boolean coercion just means, hey, when I convert something into a Boolean, do I get true or false? And remember, a Boolean can only ever be true or false. So those are the two possible values. So no matter what it is you convert to a Boolean, it will either be true or a false. Okay. So here on line 3, we see ourselves using the Boolean class there on line 3 on the right hand side, right? And I pass in this string. I am a string, and what does that give me? When I console log it out, I get back true, the Boolean true. And so in JavaScript, basically, when another way to describe something, say, hey, is this value truthy or falsy? All that means is when I convert this value into a Boolean, do I get true or do I get false? Every value in JavaScript is either truthy or falsy, right? So there's always this either or. And so rather than telling you what's truthy, because actually a lot of things are truthy, I'll just tell you what are the falsy values in JavaScript. And the good news is that there's only 6 of them. Okay. The only falsy values in JavaScript are an empty string, the number 0, null, undefined, and this thing on line 11 we call NaN, which stands for not a number. NaN is not a string. Notice how there are no quotes around NaN. NaN is its own data type, and the easiest way you can get a NaN is to say if I try to convert the string DAVID, David, into the number class is going to say, I see you're trying to take this thing and convert to a number, but I don't know how to do it, right? If I give it the string 1000 like I did on the previous slide, the number class says, oh, I feel like you're trying to make the number 1000, so here you go. If I try to convert something that just is not convertible into a number, then it doesn't throw an error. It gives me back this NaN. But for our purposes, just know that NaN is also a falsy value, which means if I convert NaN into a Boolean, I get back false. The last falsy value is a bit redundant, but it's just false itself is also a falsy value. So basically, these 5/6, if you include false, values are the only falsy values in JavaScript. Everything else, every other value is what we call a truthy value. Okay. So if we link this back now to what we did yesterday with loops, right? Now we can actually talk about conditionals in a different way. Remember how I said in the conditional is, hey, in your for loop or in your while loop, you have a conditional, and if it's true, then we keep going. If it's false, then we stop. Well, now it actually makes a lot more sense, because what that conditional is that conditional, yesterday when we wrote our loops, it gave back a true or false, right? And we asked it to. But now, one thing you realize about conditional is the conditional doesn't care if you give it back a true or a false. It will take whatever you give it, and it will convert it into a Boolean. It will coerce it into a Boolean, and it will definitely for sure get a true or a false. Even if you don't return back a Boolean to it, it will take whatever you give it and coerce it into a Boolean on your behalf. Okay. So therefore, if I look at this if loop on line 4 there, right? If 5. Well, 5 is not a Boolean, but it's in a conditional. And so what the conditional says is, all right, I don't care what it is you give me. I'm going to cast it. I'm going to coerce it into a Boolean. And when it does, it's a true, right? 5 is a truthy value. And so therefore, the conditional evaluates to true. The conditional becomes true. And therefore, we print what's in our if clause. Similarly, if I just put in the string apples in there, well, same thing, right? The conditional says, I don't care what you give me. I'm going to coerce into a Boolean. And when it coerces the string apples into a Boolean, it gets back true. And so therefore we go into our if statement and we print out what's on line 4, which is in the if. Obviously, the converse also applies there. If I look at line 10, if I say if 0, console log yes, else console log no, well, 0 is a number, but when the conditional coerces it into a Boolean, 0 is a falsy value. So when I coerce into a Boolean, I get back false, and therefore I skip my if clause and I go to my else clause, and therefore on the right hand side, when you see the printout, on the first top, lines 3 through 8, 10 is a truthy number, so I console log out yes, and then right beneath it, 0 is a falsy number, so we console log out no. The last kind of new operators we'll talk about before we talk about the last two operators is something called in common day we call it an exclamation mark. In programming we call it a bang, B-A-N-G, the bang operator. What the bang operator does is it actually takes whatever it is you put after it and gives you the opposite Boolean value of it. So here on line 4, if I say bang true, well, what's the opposite of true? The opposite of true is false. If I do bang and the string ABC, well, what's the opposite of, well, so first of all, is ABC truthy or falsy? ABC is truthy. So what's the opposite of a truthy value? A false. And similarly for all these examples here, they're all truthy. They're all truthy values, right? If I converted any of these things into a Boolean, I would get back a true. And therefore, the bank says, oh, great. Let me just give you the opposite of that and convert it into a false. Now, the other thing that we can also do is what we call a double bang operator. And actually, as you can probably imagine, what it does is it's just two bangs in a row, right? It gives you the opposite of the opposite. That can be a bit of a mind trip. And so for me, the easiest way to think about it is to think a double bang operator is the exact same thing as converting something into a Boolean, right? Because you're giving it the opposite of the opposite Boolean value. And therefore, it's the same as just saying, hey, convert this value into a Boolean. So for example, on line 4 there, if I say bang, bang, true, that just says convert true into a Boolean. On line 6, when I do bang, bang, string ABC, that's just the same as saying convert string ABC into a Boolean. And so on and so forth.
What would be the practical purpose of using a double bang?
If you're trying to convert something into a Boolean.
Oh, I see.
Yeah, that's literally what it is. You type, I think, 5 less characters.
Also, what's the etymology if you know it? Why do they call it bang instead of exclamation mark?
That I actually don't know.
Oh, okay.
Yeah, sorry, I don't know, but that is what it is. So yeah, you might also hear some people call it the not operator. In Python, there is an actual not operator, but if you say not operator in JavaScript, people know what you mean. If you say bang operator, people also know what you mean. So it's pretty consistent there. Cool. Okay, so before I go on, so any questions up to this point, right? So bang and double bangs.
Yes, you said earlier, it's just to convert something to a Boolean value. In less than 5 letters or less than 5 words. What was it about?
Oh, sorry. What I mean is, if I want to convert something into a Boolean, I can either type bang bang and then the value, or I can type out the Boolean class and coerce into a Boolean. So
I gotcha.
Okay. Yeah. So I can also, oh gosh, how Keynote? I can also type this. Right. It's just less typing. Right, so this is shorter, less typing. That's the value of it.
Oh, thank you for illustrating that.
Yeah, sorry. No, sometimes when I say it, I realize it's hard. Sometimes it doesn't come across as clearly. But yeah, it's I say it almost like a joking fashion. Like it's not anything that's like very substantive, right? Like there's no like performance or anything like that. Like a bang bang just converts into a Boolean. Okay. Sorry. Any other questions on anything we've talked about so far in this lesson? Okay, great. So the last 2 things we're going to talk about today are what we call logical operators. Logical operators are they're a bit of a beast to get with, but once you're more comfortable using them. Sorry for the crime rate in my area. Logical operators, once you get used to them, they're actually very, very powerful, and you'll see them used very, very commonly. So logical operators are also a way to kind of coerce something into a Boolean, or they're used usually to coerce something into a Boolean. So the one we're talking about first is these double ampersands. 2 ampersands. The double ampersand means and in JavaScript, and. And so what it does is it basically says 2 things. It checks to see if the first thing is a truthy value and if the second thing is a truthy value. And it will give you back true only if both things are truthy. Okay? So if I say, hey, go to the grocery store and get for me milk and eggs, and I come back with only milk, I kind of failed my trip, right? Because I didn't get the eggs. And so the and just says, if I give you multiple things, you need to give me back every single thing, right? Giving part of it is not acceptable. So if I do something like, for example, here, if I do on line 3, if I do 10 and 0, what the and operator does is it first checks the left-hand side and it says, great, 10, is that truthy? It's truthy. Okay, cool. Let's go to the right-hand side. Is 0 truthy? No, 0 is falsy. And so therefore, we're going to print out 0 is falsy, because notice how on line 3, our if statement, that conditional of the and operator, that evaluates a false. So then we go into our else statement. Okay, and just to be a lot more precise, what the AND operator really does is the AND operator, as it goes through all the things, so in this case you see as kind of chain together the AND operator, we're checking 10 and apples and 0 and null. It reads it from left to right. And so what the AND operator really is actually doing, if you want to get down to the details of it, is it actually returns either back the first false value it finds, or the last value if everything is truthy. Okay, so here what it's going to do is it's going to do 10 and this 10 true, yes, and the string apples. Is that true? Yes, and 0. 0 true? No, 0 is a falsy value, and so it will just give back 0 in this case. Okay, so it doesn't even check the fourth thing in this list because there's no point, right? If my AND operator says I need to make sure that all of these things are truthy, and I come across one that's false, I know no matter what the fourth value is, it's not going to change my outcome. I'm still going to give you back a false. So I might as well just save the extra time and stop right there. Similarly, if I do on line 7, if I say the string lucky, which is truthy, and the string number, which is truthy, and 7, which is truthy, I actually give you back 7. And so if I just look at what value is being returned, if I do an AND operator and I get back a falsy value, then it means there's at least one false in that chain. If I use the AND operator and I get back a truthy value, then it means everything in that chain was truthy. And so here on line 5, you see a console log. When we actually look at what the AND returns, it returns back a 0 in the first example because it stops at 0 because it was the first falsy value. And on the second example, it returns back 7, which is the last value, which is also truthy. So when I see the 0, I know that, hey, one of these things in here was falsy. And then when I see the 7, it means, oh, okay, everything in there was truthy. Does this make sense to folks?
Yes, because I'm sorry. The line statement on line 7 return 7 because the previous values are all true.
Yep.
Correct?
Exactly.
Okay.
I think that there's a question too.
These don't return true or false. They return an actual value.
Yes, these return an actual value. If I go back to the previous page though, notice how here we have this in the conditional, right? And so when I say this returns true or false, what happens is the conditional then coerces whatever the AND operator returns into a Boolean.
Oh, okay. So what's the next slide then?
Next slide is this one here, right? So
Okay. So all right. Yep.
yeah. So when you use a logical operator in a conditional, you know you're going to get back a Boolean value, but that's because of the conditional, not because of the logical operator. The logical operator will return back an actual value. It happens to be a true or a false, then so be it. But it will return back only a value that's in the chain of things that it's checking.
Mm-hmm. Okay, I got it.
Yep. Any other questions? Cool. If not, we have one more thing, which is these double pipe symbols. Usually I call them pipe symbols. Sorry, they are called pipe symbols, but you can call them vertical lines, whatever you want to call them. On your keyboard, they're usually underneath the delete key in the top right-hand corner of your keyboard. So if you see them, that's what they are. So double ampersand means and then double pipe symbols means or. So same exact thing. If I go to the store and I need to get back, like milk or eggs or cream, if I come back with any of those things, I should be happy, right? And that's exactly what the or operator does. Whereas the and says everything in my chain has to be true, the or operator says, hey, is at least one thing in my chain true? Okay. So here on line 4, what it does is it checks no. Okay, first thing's not. Let me check the second thing, undefined. Is that truthy? No, it's not. It's falsy. So let me check the third thing, the string happy. Is that truthy? Yes, it's truthy. Great, I'm done, and I'm gonna return that value. Similarly, on line 7, I check my first value, false. Is that falsy? Yes, it's falsy. Second value, no. Is that falsy? Yeah, it's falsy. Third value is 10 less than 0. No, that's just a false, which is falsy. And lastly, not a number, also falsy. And so therefore, I will return back the last value if everything is falsy, right? So this is almost the exact mirror image of the AND operator. Except now, as we go through it, we're just looking for at least one truthy value. So for a OR operator, if I, in this case on line 5, we return back happy because that was the first truthy value it found. And then on line 8, it returns back not number, which is a falsy value. So when I look at the output, for example, on return value 1, I see a truthy value. It means, okay, you found at least one truthy value in there, and the truthy value is happy. When I look at the return value 2, it just tells me, hey, everything in this chain that I'm checking is a falsy value, and the last falsy value is not a number. And that's pretty much it, right? A lot of materials, kind of a little bit of a potpourri of things, but they're all very, very related, and these are all things you will see very common when you program, like in the wild, we'll say.
And the logical operator example you gave, is that really used? Like, I can't really. Maybe I'm so new. I can't imagine anyone using that logical operator to just get the result and not a number as what they want to know. I mean.
Yeah, so the most common use case for logical operators is within the confines of a conditional, right? So if I think about an if statement, right? Sometimes I say I want to do this only if these 4 different conditions are met. And in that scenario, the AND operator becomes very, very valuable, right? Otherwise, I have to nest 4 layers of the if statement.
Oh, right, I understand. But I'm talking about, I'm not questioning when you would use them, but the logical operator where you're compiling different values just to, I guess, oh, I see what you're saying. You're saying the same thing. Okay, I get it.
Yeah. So for our example, if you know the false values are false, it's kind of silly to use them. But what if I'm doing an OR operator on 5 variables and I don't know what their value is? Then that becomes a lot more useful to know kind of what the values are inside of them. Yeah. Cool. Any other questions?